Hello dear students, welcome to Pen and Paper Chemistry on YouTube. Our topic for today is thermodynamics and electrochemistry. So are we covering two topics in one go? No. We are trying to correlate what we have learned in thermodynamics and what we have learned in electrochemistry. So we are going to bring down two branches of chemistry and culminate them into one. That is what we are going to do in today's lesson. When we did electrochemistry, we noted that the chemical energy is getting converted into electrical energy. There is some change in energy that is taking place. Now this, we know that the energy can neither be created nor destroyed. It only changes its form. So what form of energy has got converted? What has changed? According to thermodynamics, free energy. Free energy is denoted by delta G. A decrease in this free energy, that is minus delta G, measures the maximum useful work which can be obtained from a system. Now, when we are carrying out a chemical reaction in order to generate electrical energy, what is happening over here is the fall in free energy is showing itself as the potential difference which gives us the current in the circuit, and that is how the bulb was lighting up. We need to connect the two. We know that electrical potential is the amount of work done per unit charge. When we are talking about a cell, potential means the EMF of the cell, work done divided by the charge. Now here the charge is the number of electrons into the Faraday constant. So I have another expression for energy, that is W is equals to NF E naught. So I can write over here, connecting thermodynamics and electrochemistry, minus delta G naught, we are talking about standard conditions over here, is equals to NF E naught of the cell, right? Delta G is the delta G is the free energy, minus delta G naught is actually the decrease in standard free energy, Gibbs energy or free energy. N, the number of electrons involved in any chemical reaction. So if I am talking about an electrochemical cell where the reaction taking place is denoted by Zn plus Cu2 positive changing to Zn2 positive plus Cu, what will be the value of N? Yes, it is 2 electrons, because zinc is gaining 2 electrons, zinc is losing 2 electrons. On the other hand, copper is gaining 2 electrons, right? Let's suppose I replace zinc by silver, right? Of course, the reaction will change automatically. So if we have, instead of zinc, I am taking silver, right? Now tell me, how many electrons will be involved in this change? Yes, it will be again 2, because the number of electrons lost has to be equal to the number of electrons gained. So N gives you the number of electrons. F stands for Faraday constant 96500. E naught cell, that is the standard EMF of the cell. So we have the first expression over here, correlating thermodynamics and electrochemistry. Both of them are representing in different forms of the energy. So minus delta G naught is equals to NF E naught of the cell. Earlier in thermodynamics, we had also done minus delta G naught is equals to RT natural log of Kc. Here, R is the universal gas constant, T is the temperature in the absolute scale, that is the temperature in Kelvin, Natural log of Kc. Kc stands for equilibrium constant. Supposing we are talking about a reaction which is come to a stage where it is in equilibrium. How do we represent a reaction in equilibrium? By a double-headed arrow. So we have Zn2 positive plus Cu over here. So if we are talking about an equilibrium state, then minus delta G naught is equals to RT natural log of Kc. Therefore, I will connect the two expressions. I have NFE naught cell is equals to RT natural log of Kc. Right? Now Kc is a term which we had done under the heading, yes, chemical equilibrium. So if you notice over here, delta G is an it's an expression which is helping us to correlate three branches of chemistry and bringing them down to simplify it into one. So NFE naught cell is equals to RT natural log of Kc. NFE naught cell is equals to 2.303 RT log of Kc. Now it depends which expression you are going to use. If you are using a calculator and you are allowed to use your calculator, then you use the first expression because you can easily work with natural logarithms. But if you are not allowed to use a calculator, I would request you not to experiment with one and go on to this expression where we have converted the natural log to base 10. That is, you can easily use the logarithmic tables which are given in any of the books. Usually you will find these logarithmic tables either given as an index, as an appendix at the end of the textbook, or you find them as separate tables. So if you are using logarithmic tables, you use this expression. Oh, so you don't know how to use the logarithmic tables? Don't worry. I have put 2 videos on using and applying logarithms to difficult calculations. So we start from the basics and we bring them down to very difficult ones as well. My request to you will be, if you are not confident about logarithms, just watch those 2 videos with a pencil and paper in your hand and you will be very confident at the end of those videos. Right? Now what you have to do is to attempt, that's the homework, 10, only 10 numericals based on these 2 concepts. Now when you do the numericals, you will also realize that we had spoken about delta G as telling us about the spontaneity of a reaction, whether a reaction will take place spontaneously or not. Can you recall that? Yes. If delta G is negative, I am talking about only delta G. If delta G is negative, the reaction is spontaneous. If it is equal to 0, then it is at equilibrium. So we have 3 expressions here. Okay, let me make space for that first. So in thermodynamics, we had done that if the value of delta G, I am not talking about negative delta G over here, I am talking only about delta G. If delta G is less than 0, the reaction is spontaneous. Delta G equal to 0, reaction is in equilibrium. Delta G greater than 0, the reaction is non-spontaneous. Right? If you are not clear about these concepts, please go to the videos on thermodynamics. Each and every point is made very clear and you will be able to relate to that. Now, minus delta G. If your delta G is negative, so what will be minus delta G? So if it is negative means, let's suppose it is minus 2. So minus times minus becomes plus, right? So the value of E naught cell will become positive. So for a spontaneous process, EMF of the cell is greater than 0. If it is equal to 0, then the reaction is in equilibrium. If it is less than 0, that means it is non-spontaneous and it will take place in the reverse direction. Why I am mentioning it over here is there are numericals asked where they ask you, will this particular reaction take place or not, right? So either you can work your way around with delta G or even E. So get going. 10, only 10 numericals. Sit down. Don't postpone it. Don't think that this is another video which you watched on YouTube and that's it and you hop to another one. If you are not clear, rewind, play it again. Keep a pencil and paper in your hand so that you can write. When you write these down, they become your notes. So you won't have to look outside for notes. These are your notes. That is why I am writing everything on the board, so that once you copy it down, your notes are compiled in your own handwriting. And from my experience, I can tell you whatever you write by your own hand remains embedded longer and is much more clearer compared to if you take printed notes or typed notes from anybody. So just write, so that hand-eye-mind coordination will work wonders for you, and at the end of the topic I will see a big smile on your face and my purpose will be served. Happy studying to all of you. Stay subscribed and don't forget to share. See you in the next video.